Thank
More. Yes.
you. Okay, sir. Uh, Good afternoon, everyone, respected faculty and research scholars. So, this is Thirumala. I am doing PhD first year under the guidance of Professor Arnab Ghosh in Electrical Engineering, NIT Rourkela. So, today my topic is regarding the forecasting of solar energy using ML approaches. So, now I can go for the contents. These are the contents. Shall I explain in this PPT? Introduction, solar forecasting parameters, dataset resources, conventional approaches versus ML approaches, literature survey, different ML methods, results and discussion and conclusion. So then we can go for the introduction. Nowadays, the all work is, especially in the field of forecasting, we are using the machine learning and also deep learning. So forecasting is nothing but to predict the future values. So not only here in this field, I am using for solar. We want to predict any rainy data or wind data or any data we want to predict accurately. So nowadays we are using the ML and DL also. For the more complex problems, we can go for the DL. Comparing with the some problems which are not related to that much complex, we can go for the machine learning techniques. So in this my project, so I can go for the different types of ML methods. So conventionally, we are using so many methods like as climatical methods and physical methods. So many methods we are using, but still no, they don't give accurate value. Means they do not accurately forecasting the solar data. So that's the reason nowadays the all research work is going on by the, especially for the forecasting, they are using machine learning. So forecasting the solar data is important. Why it is important means nowadays everyone can know we are using solar data. Why we are using solar energy? So solar energy is the primary energy in our universe. So solar energy without cost we can easily capture from anywhere or any place. So it is comes under a renewable energy. Nowadays, the all research work is going on the integration of renewable energy with grid, and also some power systems, and also to manage the energy. So especially for the applications of the efficient energy management systems and the renewable energy integration, and also for grid stability, the forecasting of the solar data is very much important. So in that case, we definitely go for the accurate methods. So conventionally, we are using so many methods, but they are not that much of accurate. So nowadays, we are moving for the machine learning methods. So while we are going for the solar energy, what are the parameters we want to consider to forecast, especially for the solar energy? So these are the parameters we want to forecast. So first one, we can go for the solar radiation. What is meant by solar radiation? Everyone knows how solar energy per the unit area, and we know that the units are watt per meter square. Solar radiation is the main parameter which is the target variable. Especially in ML, we are treating variables in two types. First one is the feature variable. Second one is a target variable. So feature variables which are accepting from the target variable. So target variable, we can target that variable. We want to predict that targeted variable with the feature variables. So next we can go for the second one is the temperature. Already we know when temperature is very much high means it means the temperature is increasing. Obviously, the solar radiation is decreasing. The relation between the solar radiation temperature is inversely proportional. And then we can go for the wind speed. Wind speed. So wind speed is mainly affect the solar radiation. In sometimes already we know in hilly areas the wind speeds are so much high. We can go for the any low means we are go for the any plain areas like that. The wind speed is so much less. So definitely the wind speed also affect the performance of the solar radiation. Then we can go for the wind direction. Already we know the directions are north, south, east, and west like that. So wind direction can can radiate the solar radiation. Sun rays, it will radiate, means it will distribute in different directions. So wind direction is also somewhat affect the solar radiation. Then we can go for the humidity. So in our sky, the humidity is everywhere is there. So if in case the humidity is increases, then it ultimately leads to the decreasing of solar radiation. So we can tell like that the humidity is inversely proportional to the solar radiation. Then we can go for the parameter of cloud cover. When clouds are passing, in that time, then the cloud can cover the sun. So automatically the sun rays falling on the earth are somewhat decreasing. So the cloud cover is also a badly affect on solar radiation. Then we can go for the air pressure. Air pressure is also air pressure. When everyone know when so much of sunny days is more, automatically the air pressure is increasing. When the sunny days are less, automatically the air pressure is decreasing. Then we can go for the day of the year. So that day of the year definitely affect the solar radiation. Everyone know. Generally we have the three seasons: rainy season, winter season, and summer season. So I think everyone knows in summer season we are getting so much of sun rays. So we can easily collect so much of abundant energy of solar. So every day means the day of the year is definitely affect the solar radiation. Hour of the day. So hour of the day means forenoon, noon, and afternoon. So these hours can affect the solar radiation. In noon time, we are getting so much of solar radiation comparing with the forenoon and afternoon. Next, we can go for the solar zenith angle. It is the angle which is vertical location to the sun. So when the solar zenith angle is so much less, then it indicates that we are getting so much of solar radiation. While we are it means the solar zenith angle is increases. Obviously, we are getting less solar radiation data. Then we can go for the next parameter is sunshine duration. Everyone knows. So in during daytime we are getting sunshine, means sunshine duration is more, especially in the summer comparing with the winter and rainy seasons. So the sunshine is also a affect the solar radiation. Then we can go for the precipitation. In precipitation, mainly it involves rainy and snow. So the when rain is falling, and also obviously snow is falling in winter, when it fall down, automatically it will badly affect the panel structure. If in case, for example, we are using one solar panel, it does not cover properly, means it does not have any protection. In the time, the small droplets of rainy and also somewhat of the snow is falling on the panel, automatically it will this means somewhat means the sun rays falling on that panel is somewhat disturbed, means that much amount of sun rays are not falling on the panel. Then we can go for the aerosol optical depth. Especially the aerosol optical depth, AOD, is referring to the pollution, air pollution like that, and the dust, whatever the dust and the air pollution is present in the sky. So nowadays we are everyone know, from the few past years, now we are in the 2000th century. Compared with the 19th century, in 2000th century, the CO2 is abundantly increases. So automatically the air pollution is increases. So it leads to decrease the solar radiation. Then we can go for the main two parameters, which are the subclassifications of the solar radiation. First one is the GHI, and the second one is the DNI, global horizontal irradiance and direct normal irradiance. Both are the subclassifications of the solar radiation. Global horizontal irradiance is nothing but we can take the we can tell like the sun rays are horizontally placed falling on the earth surface. Under direct normal irradiance, we can tell as the sun rays which are exactly falling perpendicular to the earth surface. So these are the parameters while we consider to forecast the solar energy. We are considering these parameters. Then we can go for the dataset resources. So okay, still now we are seeing which parameters we want to take. We see here. So where we can get these parameters? Yes, obviously we can use the resources. So here so many resources is there. I think around 15 resources is there. So obviously, the 15 resources are giving the parameters what we require. But especially, I highlighting some means some data resources which are easily available to forecast anyone. The first one we can go for the NASA. So NASA is a free data source. It can easily provide. It means you want to download any data. I mean any data parameter. Not only I'm telling about the solar, we can download the parameters regarding the wind forecasting, the any forecasting, and also the field regarding the agriculture field anywhere. So any data you want, you can easily download from the NASA also. Then we can go for the PVGIS. The PVGIS is nothing but a photovoltaic geographical information system. It is especially used for the who are working with the image data. So it will give the good amount of the image data comparing with the regression data. Then we can go for the NSRDB, the National Solar Radiation Database. It is a hub of data. It can give the it especially in a National Solar Radiation Database. It is only means it especially means particularly available for the solar radiation data parameters. Then we can go for the solar anywhere. Solar anywhere. So any means any in our old so many countries is there. So you can track the any country solar radiation parameters easily. Then we can go for the meteonorm. So meteonorm is nothing but it is especially give the meteorological data comparing with the historical data and wind prediction data. It will give the meteorological data. If you which one works for the means meteorology, especially we want to collect a meteorological data, we can go for the meteonorm. Then Solcast. Solcast is nothing but it will forecast. It will especially use it for the forecasting of solar energy, and also remaining is also there. Like as Copernicus atmosphere monitoring service, it especially means more. It will give the so much data parameters regarding the atmosphere along with solar and the global energy forecast competition. Means this is also a data set available, but we want to pay. Definitely we want to pay. And also European Solar Data Atlas, means especially for the European countries, they are using these data resources. And Helio Clim data set, Clim data, I mean Helio Clim data set. It is also give a database, and also an NREL, the Renewable Energy Laboratory data sets. Means that laboratory, means the National Renewable Energy Laboratory, they will provide the data sets regarding the all renewable energy. Not only I'm telling about solar, they will provide wind energy and geothermal energy. Means which parameters we want, they will provide. But we want to pay also. So here some of the free sources is there, and also we want to pay money also. And the last but one, the solar data warehouse. It is a data data storing web house. It can easily, it means in this so many data parameters are available. So comparing with the remaining data source, it is somewhat advanced. But here, if you want data, if you can pay also. Also, especially still now, I am using the NASA data and also NREL data. I am this project I am done with the data of the NASA. Then now I can go for the methods which we are focusing on. Already everyone know the conventional methods and the ML methods. They are easily available for the forecasting work. So now we look on the conventional approaches. The first one is the persistence model. Persistence means exactly. For example, last month I got some solar power around. For example, I tell as a 2 kilowatt power I got. So the persistent model simply it will just replica of that month energy. Means for example, it will for next month it will forecast like a 1.9 kilowatt or otherwise 2.1 kilowatt like that. So persistence model is nothing but it simply focus on the means it will simply replica of the previous data. It will not accurate method we can consider like that. Next, climatology data. The climatology data is a the history of data it will contain. Means fast 4 years, past 10 years, from last decades onwards, it will contain the historical data. But the climatology model we want to learn, we definitely learn the dynamics of the air, and the thermodynamics. Regarding the subjects, we definitely learn. So the climatology model is okay, somewhat good, but you want to analyze the forecasting work by using this climatology model, you definitely learn so many things. Means you want to learn, you can means here so many means mathematical equations and mathematical models are involved here. So it is somewhat difficult comparing with remaining models. Then we can go for the physical model. The physical models, which are based on the physical works. It is somewhat related to the climatology model. And we can go for the numerical weather prediction. So numerical weather prediction is nothing but it is simply equal to the mathematical model. So if you want to forecasting the next month data of the solar, then if first you want to design one mathematical equation, means mathematical model, first you want to design. Then after you can easily forecast that. So who do not exporting the mathematical modeling equations, so they are not easily work on with numerical weather predictions. Then we can go for the ARAMA and SARAMA. ARAMA, auto-regressive moving average, integrated moving average. SARAMA is a seasonal ARAMA. So both are the time series models, which are somewhat best comparing with the remaining conventional approaches. But still now it will involve so many statistical calculations. So you are exporting statistical methods, then that person can easily understand the what ARAMA and SARAMA models can do. So who are not good at in statistical models, they are not means they are not unable to use these models. Empirical models, these are also somewhat related to the physical models. Here also the data which is available for the meteorological data, history data, and anywhere is there. But these models also somewhat difficult while we are working on it. Then we can go for the ML approaches. I think everyone know in ML so many algorithms is there, but most of the case these algorithms we are using support vector machines, a decision tree, the random forest, and the GBoost, AdaBoost, XGBoost, KNN, linear regression, lasso, ridge, and elastic net. So in next slides we can see the explanation for the one by one these ML methods. Literature survey. Here, still now I am reading so many papers, but the updated papers I am listed here. The title of the paper, ML or the DL methods, which we are using that paper, it will contain it here. Next year of publication, the journal name, the volume number, and the page number, and the DOI. So the title, the first paper is the a day-ahead PV power forecasting method based on the LSM and RNN model and the time correlation modification under partial daily pattern prediction framework. Especially, they will consider the solar data under the partially daily pattern. Partially means maybe cloud can cover the sun, maybe humidity is high, maybe precipitation maybe is high. In the type of scenarios, they will consider the data and they will work with the DL method like as LSTM or RNN. LSTM and mathematical long short-term memory, and the RNN is a recurrent neural network. And also they combined, especially in this paper, they're focusing on the three methods, LSTM, RNN, and the hybrid model of the LSTM and RNN. Next, we can go for the second paper, a review on deep learning models for the forecasting time series data of solar irradiance and photovoltaic power. So, especially this paper containing, this is one of the review paper. It will give the brief description of the ML and DL methods, especially RF, SBR, CNN, LSTM, GRU, and MLP. Especially this paper containing so many methods, but RF, SVR, CNN, LSTM, GRU, and MLP are give the best results. And among of them, the hybrid model CNN, LSTM give the best results comparing with the remaining models. The third paper is nothing but a solar photovoltaic forecasting power output using LSTM networks. In this paper, they are focusing on the only LSTM networks and also with the hybrid models. In this paper, the mainly they are using three methods, means three algorithms, LSTM, RNN, and the hybrid model of LSTM, RNN. Then we can go for the fourth paper, the day-ahead hourly photovoltaic power forecasting using attention-based CNN, LSTM, neural network embedded with multiple relevant and target variables prediction pattern. So the paper is containing, especially this paper is means work on with the hourly data. Especially while we are working with the solar data, we are considering the we can considering the some parameters, means small data sets, medium data sets, and large data sets. So in small data sets, means it will contain the data regarding the hourly for hour to 1 day. While we go for the medium data, means medium term of data, it will containing the data regarding the days to weeks, approximately equal to month. When we can work with the long terms, means lengthy data, it will containing the data with monthly, months, and years. So especially in this fourth paper, they are focusing on the hourly data, means they are using a low small data. Hourly data they are focusing on. Especially in this, they are working with the CNN LSTM model. Now I can go for the my continuation of the literature survey. The next paper, the fifth paper is CNN LSTM, an efficient hybrid deep learning architecture for predicting short-term photovoltaic power production. So this is also a considering a short term. So short term means small data, means it will containing the data regarding the hourly to the some hours to the 1 day. Here they are focusing on the methods like as LR, linear regression, LSTM, CNN, and LSTM. Then we can go for the next paper, a hybrid deep learning based network for photovoltaic power forecasting. Here they are using a one hybrid deep learning method. Like all day we are discussing. So a hybrid methods means combination of any methods, means ML or DL method, or combination of two ML methods or DL methods. Here they are focusing on the combination of some DL methods. LSTM, CNN, first they are using. After that they are go for the CNN LSTM model and the LSTM CNN model and the GRU CNN model. Different types of hybrid models they are used here. And then we can go for the next paper, the machine learning based solar photovoltaic power forecasting, a review and comparison. Especially this is also one of the review paper. From this review paper, I want to work on it, and also I will use some of the methods here usually here, like algorithms, KNN, SVM, DT means decision tree, ensemble learning machine means ELN, RF, RNN, recurrent neural networks, and deep neural network DNN. They are using the both ML and DL methods here. In this review paper, they review the all methods with the data set. Then we can go for the last paper here, the machine learning based forecasting of temperature and solar irradiation for photovoltaic system. So this paper is also they are describing about the here majorly they are focusing on the forecasting of temperature and also solar irradiation. This paper forecasting the in two different ways. Especially in this paper they are using two data sets. One data set, the target variable is the temperature. In another data set, the target variable is a solar irradiation. By based on that, they will use the methods such as DT, tree, random forest, SVM, extra gradient boosting means XGBoost they are using here. Out of that, XGBoost give the better results comparing with the remaining ML methods usually here. Especially in this paper, they are using two types of data sets and they are compare the results. When they forecasting the temperature, they will apply the data set to the all algorithms, and also while they are forecasting the means where they are targeting the solar irradiation, in that also they are using these all ML methods and compare. Finally, they compare the results here. Results in that regarding the temperature and solar irradiation, they compare the performance metrics for the both for both data sets. Next, here we are discussing discussing about the different types of ML methods clearly. So first one is the SVO, support vector regression. Support vector regression is a powerful data set here. In especially in ML, there are mostly there are three types of learning techniques is there: supervised learning, unsupervised learning, and semi-supervised learning. While we are working with the regression data, we are using both learning methods. Maybe supervised learning methods we are using, Otherwise, we can go for the unsupervised learning methods also. In supervised learning method, we can expect the output. Means whatever the output we are getting, we can simply expect. Means we can easily expect. For example, for SVR, I feed two types of data. For example, I am assuming like my blue color is data and red color is another data. Means for example, I take a blue color is variable A and red color is a variable B. So in both variables, some common data is there. Means common data variables is there. In that time, how SPR can work? SPR can simply work for the different data available, different data variables available there. SPR uses a one hyperplane. The hyperplane can easily it is a plane. It is a two-dimensional structure. It can increase. Means it will increase the it will increase its margin. In that margin, it will collect some data points. For example, blue is a variable A, red is a variable B. Variable B. Out of these two variables, the data which is similar, the hyperplane can easily gather the data by using its margin. So likewise, for example, we are go for the solar radiation. Like that also, for example, variable A we consider as a temperature. Variable B we are considering as a cloud cover. So, for example, the data variables regarding the temperature and cloud cover, which data variables support the means which are having the linear or non-linear relation with the um, solar radiation data points, it can easily collected by using its margin. Then we can go for the RF. RF means random forest. It is one of the important ensemble model. Ensemble means a combination of different models. SVR is a single model, but RF is not a single model. It consisting of so many means ML models. Like we are taking as an example, we are taking as a tree, means decision tree. First, I am take a tree 1, tree 2, tree 60 means how many trees we want, we can take according to our complexity of the problem. According to we can take the different types of trees. Here, the tree 1 is again means splitted. I can take my red means red point means red point. What is the node? The red node it indicates that parent node. Then the parent node is divided into two child nodes. Again, the child node is divided into grandchilds. So here the data is flow like this. For example, my red, blue, brown we are considered here. So the data is passing from parent to the child, again child to the grandchild. Here, while we are assuming that the red, blue, brown combination give the best data, means the best prediction. Okay, so many nodes is there. First, I am considering that the red, blue, brown line is indicating, means it will give the best prediction value comparing with the remaining combinations. In that time, I can use this combination. For example, from the tree 1, I am use this. Tree 2, I am using the red, green, some blue color of like that. Like that, I am using this structure. So RF is nothing but it will contain so many decision trees. According to the decision tree, the data is first the first data is flowing through the parent node. Then it will go to the child node. Then again the child node is subdivided into grandchild nodes. The data is simply transferred from the parent to the grandchild. So which path gives the best prediction? That path can follow the data. And finally, all predictions. For example, here I am using 60 predictions. For example, I told like that. So I am using, I simply average the all predictions. So like this. So generally the RF can works by the sequential ensemble model. Especially in ensemble models, there are so many methods is there, but the majorly they are using sequential models and boosting models. The RF can easily work on the model of sequential. In a sequentially, the tree 1 predict. Sequentially, tree 2 predict. Sequentially, up to how many trees is there, it will predict. Means here the predictions are averaged. Means the variables, means the data containing in the parent node, child node, and grandchild node. We are here. I mean that steps we are not averaging the data. When the data is reached in the prediction, that time we are averaging that all predictions. So before that, the all trees they are works means they are operate individually. They are operate sequentially, not depends on one by one. They are operated sequentially. Then what are the predictions is there? What are the predictions given by the RF? For example, here we are using 60 predictions. We simply average at all predictions. Then we can get the final output. So then we can discussing about DT and RNN. So KNN. DT is a decision tree and KNN is the K nearest neighbors. So DT decision tree. Already we are discussing there in RF also. DT is a one of the model, one of the subpart. We are one of the subpart for the RF decision tree. Here the first one is the root node is there. We can called as a parent node also. The root node is next divided into some decision nodes. Decision node 1, node 2, like that it will divide. Again, we can go for the decision node again divided into leaf node. At the when the data is sufficient at the leaf node, then it can stop. Means here the data is flowing layer by layer. Here the decision tree is nothing but it will data is flowing layer by layer. Means node by node the data can flow like this. When whatever the prediction we want, the leaf node it reach the leaf node it terminated. For example, I am calling as the decision node. First one as a layer 1 means a depth. We are calling as maximum depth 1. Then we can call leaf node decision maximum depth 2. Again we can leaf node is the maximum depth 3. So depth 1, 2, 3 layers we can consider like that. At the third layer I will get the whatever the output I want I will get. Then can the DT can stop. That means the algorithm working on it will stop. Otherwise it will goes on up to whatever the predicted output we want. Up to that the DT can work on it. Then we can go for the KNN. So KNN is a K nearest neighbor. We can call as a KNN is a lazy learner. It's simply lazy. It will not work by its own data. It will simply collect the other node data. I am calling class A is one data, class B is another data. Means red one is one data and red 3 is another data. The KNN simply use the Euclidean space. It will create some circles. I mean, it will create some space. K3, K7, K9. We can take even numbers also, odd numbers also, by based on our requirement. Here in this case, they will consider K3, K7, and K9. While I'm considering the K3 Euclidean space, here the data, means the class A, one data node. From the class B, two data nodes are here. And also the question mark indicate the K, mean K value. Sorry. The question mark is the we want. It is give the predicted value what we require. So when here the class A one that means data node is there. From the class B, here two data nodes is there. The KNN is simply work on it. Which data node is nearby it? It will easily collect the data from that node. It will not work on its own data. It simply collect the data which is given by its nearby its node. For example, the green data is, I mean, the green data node points are near. It will simply collect the data from the green nodes. So we are telling like here we are discussing about KNN is simply it is a lazy learner. It will do not create its own data. It simply collect the data points which are nearby in its Euclidean space. Next, we are discussing about models. Nothing but a different means I am already told that ensemble methods, they are combination of different ML models. Likewise. Here first we are discussing RF, then we can go for the XGBoost and ADA-boost. XGBoost, extra gradient boosting technique. ADA-boost, adaptive boosting technique. XGBoost, first we are clearly understand that sample input. For example, I give some sample data to the XGBoost. What it will split the data into two steps. Especially in ML and DL problems, the data set is first the data set is trained. After that, it will testing. But first, it will reach the phase of training phase. After it, we can go for the test phase. So the data is shifted splitted into two sets: training set and the test set. And also, especially we are working with the ML and DL methods. the training data set and testing data set, they are not equal. We are giving so much of data to the training and less data for the testing. 80% of the data in generally the role is there. 80% is 20% role is there. 80% of the data is training and the remaining 20% of data is tested here. So likewise, we are working with the XGBoost. First, the sample input is divided into training set. Some of the means 80% of the data is training and the 20% of the data is testing. Then we can go for the means then what happened? Then in training set, sample perturbation means here means the data is divided into so many samples 1, 2, 3 up to n. And also now the XGBoost is working its working. It is also similarly working sequentially. For example, set one data is operated by the XGBoost, means the data is trained by the XGBoost 1. And also sample set 2 is trained by the XGBoost 2, XGBoost 3, XGBoost n. Like that, we are considering n XGBoost models. We are easily training the XGBoost models by based on the data sets provided by the sample sets. Finally, we are integrating all the outputs. In integration step, we are simply sum up the all the data, means all the output which is given by the XGBoost models. Then we can go for the ADABoost. So ADABoost is nothing but adaptive learning method, means adaptive learning method. So ADABoost is it will simply adopt the data. So it is simply how it works. So first we can train the data. Yes, obviously we can train the data. It may be non-linear data. So maybe it is linear data, maybe non-linear data. We simply train the data. In training, in especially in ADABoost, it will contain so many weak classifiers, means weak learners. So for example, my weak learner 1 is there, weak learner 2, up to weak learners K is there. So my weak learner 1 gives some, okay, it will give some output, but in badly, means it will not give the predicted output. Then I can go for the weak 2, weak classifier 2 and weak classifier K. Up to that, which means which classifier can give the best output, can I stop there? And also I sum up the all the predictions which are given by the weak learners, and I can form a one new strong learner, means strong classifier I can form. Means when the weak learner classifier 1 can log any data, I can easily provide it. By the weighted vector, I can easily add that data to the weak learner 1. For example, weak classifier 2 can means loss any data. Okay, we can easily add with the weighted water. So likewise, in ADABoost, the features, means the output which is given by the weak learners, we can only sum up, and we can create a, and we can design a one strong learner. After the strong learner is designed, it will obviously give the whatever the predicted output we want, it definitely generate. Means ADABoost is nothing but the name itself would indicate that whatever the data available at the weak learners, it is simply adapted by the strong learner. So then we can go for the regression models. And especially ML, the regression models is also there. The one which one is a simple regression model, which is nothing but a linear regression. It is a simple regression. It can give the only give the relation between the target variables and features with the linear and not linear, non-linear. So if in case whatever the parameters, means I already told which one we can target, the parameter is called as the target parameter. The remaining parameters we are called as a feature variable. So it will give the linear relation between the feature variables and the target variables. Here so many data points is there, and also it will only give the relation between the targeted variables and feature variables with linear relation. Means for example, we are considering the solar radiation is means is a linear with wind data, wind variable. So it will form one linear relation. Like that, it will form the solar with solar irradiation with the remaining feature variables with a linear relation, and it will predicate the output. Next, we can go for the lasso regression. So lasso regression is a one of the type of linear regression, least absolute selective shrinkage operator. It will simply shrink the operator, means shrinkage operator. For example, the data is overfitted, especially while we are working with the ML models, the data may be underfit, correctly fit means critically fit, or overfit. When the data is, for example, the data is overfitted by the model, then automatically the lasso regression can zero the value, means whatever the data points give the overfitting, means which will leads to the means overfitting, that the data points are simply make zero by this lasso operation. Especially in a lasso regression, we are using the lambda 1, means simply called as a L1 regression model. The lambda 1 is a controller, is a regulator which can regulate the penalty, means how much of penalty I will give to the higher order variables which will create the overfit. I can simply how much of penalty I will give to that parameters which will create the over data flow, which can be decided by the lambda 1, means regulation parameter lambda 1. Then I can go for the ridge regression. Ridge is also a one type of linear regression. So ridge we can simply call it as a L2 regression. So it is similar to the lasso regression, but here what happened in lasso, we simply zero the higher order terms, means which data will cause the overfitting, we will simply zero that values. But here we can simply average that higher means higher data values which were lead to the overfitting. We can simply average that data values by the use of L2 regulation. In lasso, we are using L1 regularization, means lambda 1. In ridge, we are using L2 lambda 2 regularization for controlling the how much penalty we are giving to the higher order terms which are lead to the data overfitting. Then we can go for the elastic net regression. So elastic net is simply nothing but it is a combination of lasso and the combination of lasso with ridge. Here, two penalty factors is there. Lambda 1 is there, lambda 2 is there. Sometimes we call lambda 1, lambda 2 is beta 1, beta 2 also. No problem. Where parameter we are used, we can use the parameters like that. It is a simply whatever the advantages which are created by the ridge and lasso, it will easily combined by the elastic net regression. So we can term elastic net as a hybrid model. Why? Because it contains the features of ridge and lasso. So up to now, I will complete all the theory regarding the ML. Now I can go for the results and discussion. Especially in my project, whatever the project I will done here, it is I am using a 1 year data. It will contain the parameters. See here in this matrix. See here carefully: radiation, temperature, speed, direction, hour, day. I take this only parameter. In my previous slides, I discussed so many parameters, but I will use this actually one of the data paper. It will containing these data parameters. Actually, I will show the paper also. Yes, this is the 27 to 2024 paper. In this paper, I am using the data set regarding the solar irradiation. The data set I simply take and I will work on it. So for the data set, I will use the Python code for writing the code. Here I am using so many ML models, and also I am using this dataset parameters, means radiation, temperature, speed, direction, hour, and day. Especially I take the 365 days, means 1 year data I will collect, and also I predict the next 1 year data, means I forecast the next after 1 year data. Here my radiation is my target variable, temperature, speed, direction, hour, and day are my feature variables. My target variable, I indicate my target variable with y-axis by target value, means radiation, and also my feature variables I will indicated with my x-axis, temperature, speed, direction, hour, day. In results, first we are focusing on the Pearson correlation. After I will move for the Spearman correlation matrix. How the Pearson correlation matrix is created? Here, the Pearson correlation matrix is simply describe about the how the feature variables and target variables are related. Like we are day. Here the row containing day and also column containing a day. So when we clearly observe that where the one value is occurring, one means maximum value. When we are getting one means the data parameters are same. Yes, data is same. Obviously, we are getting one. When I work with hour with day, here the day is against with hour. In that time, the the matrix value is matrix value is 0.0038. Like that, here we are means we are creating a correlation matrix for the feature variables against with the target variables. Here also we can draw the Spearman correlation matrix also. Why I can draw both means, especially while we are working with a linear data, means the feature variables and also the target variables both are in linear manner. We can draw the Pearson correlation matrix. But for example, any non-linearity is there, means obviously is there. The solar radiation is always not linearly vary with feature variables. Definitely it will vary with means definitely it have non-linear relation with the feature variables also. So that's the reason I can draw the Spearman correlation matrix. While we comparing with both Pearson correlation matrix and Spearman correlation matrix, both we can draw for the linear relation data and non-linear relation data between the target variables and feature variables. But while we comparing with the Pearson correlation matrix, Spearman correlation matrix is somewhat advantageous, and also it will predict the values accurately comparing with the Spearman correlation matrix. Then we can go for the results. Here the first one is the linear regression. Here the first one indicate training data, and the second one indicate means 0 to actually I am taking here 365 days of data. Here 80% of the data is around 272, means 0 to 272 days is trained, and 273 to 365 days are training. Here we can clearly observe that the blue color is indicating the actual radiation data in that years, in the days, and also the green color is indicated that means the light the dotted green color line indicated that the linear regression data which is predicted in training phase. Here we are seeing that the linear regression is not working properly. Why? Because for example, we will take for example we are observing 0 to 50, means 0 to 50 days. See clearly the solar radiation means the actual data reaching the radiation value of 1, means around 1, 0.8, 0.9 like that. But what linear regression do? It will simply forecast, okay, but up to 0.7 it will predicate, means some deviation is there. So definitely the linear regression model containing some errors. That's the reason it will not predict that much of accurate comparing with remaining models. Then I can go for the next graph, the future predictions with seasonality, linear regression. Here the predicted radiation for the next year. Here I am using a 1 year data for the training and testing phase, and also 1 year data for the means 1 year data I will predict. I am not using any future data. I will simply predict the data for the upcoming year. Here in this it will contain 3 seasons: winter, summer, rainy, like that. In winter we can clearly observe that yes, obviously is there. In winter it will containing the 0.8 radiation. In summer it was some 0.9, but in rainy it will containing somewhat radiation data simply equal to the 1. Then we can go for the next random forest. Here you can see the actual data and the training data. Both are merged, means both are similar, means the random forest algorithm can works better, and it means the actual data is somewhat means closer to the the predicted data is somewhat closer to the actual data. So here, in case the error is somewhat less, while we are seeing the training data and testing data, the prediction is simply closer to the actual value. Comparing with linear, we can see here the random forest works better. So here the future prediction with seasonality random for here also this is the 1 year data. We can same. I can use all algorithm. I think around 11 algorithms I'm using. I can follow the same pattern. Means first 1 year I will predict. Means first 1 year I will train the data. Training and testing the data. After the 1 year I will predict the data with this different seasons: winter season, summer season, and rainy season. So here the winter season started. Generally, winter season is started November and the rainy season is ended October. Like that, I will take the months. I'm not taking the months from January to December. I'm not considering like that. I'm considering like that from November to October. From November to February is the winter season, and March to the June summer. From July to the October rainy month, rainy season. Here we can see clearly. So random forest results was somewhat better compared with the means linear regression. Here we see the from the winter and summer almost here the prediction is not reaching the upper limit value. Means 1. Here almost all means in summer also almost all it will reach 0.9. In winter, in rainy also it will reach the value of 1. Then we can go for the XGBoost. Here see also like that RF XGBoost also accurately means the training data is simply means it is easily close with the actual data in training phase and testing phase. Then we can go for the different seasons. Here also we are considering winter, summer, and rainy for upcoming year. Here also we can observe that in 3 seasons the value is maximum 1. Maximum it will reach the 1 means upper value of the predicted radiation it will reach. Then we can go for the SVM model. Here also we are train the data and test the data for the 1 year. Here also you can clearly observe that SVM is somewhat not close to the means it's somewhat close, but that not that much close to the. For example, you are see XGBoost. It is means the actual data and the trained data is easily means it is close. It is nearby that. But see here in SVM the training and testing data is somewhat far away, means little bit far away from the actual value. Then we can go for the future prediction. You see here in winter, summer, rainy. Almost all in summer and rainy, the SVM is not predicted very much. So it will badly predict. So in my case, the SVM is not giving good results. Then I can go for the decision tree. See here, the decision tree is we can tell that it will 90% means 90 to 95% it will exactly close to the trained data and test data is 90 to 95% is exactly close to the actual data comparing with the remaining models. Here see here the future prediction also especially in winter means rainy and summer almost all it will reach the maximum value of the predicted radiation. Then we can go for the KNN. KNN is also somewhat deviated. The trend data and text data is somewhat deviated from the actual values. And also future prediction. We can observe that it will only reach the 0.8, not the maximum value, like that. Then we can go for the ridge regression. It is also like a SVM. It will not predict good. We see here, if for example we consider 0 to 50 days. The prediction is averagely 0.6, but the actual is up to 1 to 0.9. So the ridge also not means ridge also not give that much of good results compared with the remaining. See here clearly, except rainy season, the summer and the winter seasons, it is not clearly predicted by the ridge. Then we can go for the lasso regression. Here also we can clearly observe that it will not also actually means it will not also accurately predict the both means it will not automatically in here we can observe that the train data and test data are not somewhat close, means yeah, is somewhat not somewhat, it is deviated from the actual values. This model is also not giving best results. And also similarly we can see here, especially see the point 0.5, it will not upper value, it will not reach the means medium level of the predicted radiation also. It will not reach the 50% of the predicted value also. Means here this the lasso also does not give the future predictions better. Then we can go for the elastic net. So elastic net, obviously we know it is a combination of lasso and ridge. Obviously he see here lasso give best results and ridge also gives means not perfect results. So how elastic net work? It can simply work the work the operation of the features, means advantages taken by the ridge and the lasso. But still no, the elastic net is containing both lasso and ridge. Still no, it is not. It will not give the good result. Means not accurate result what we want. In training data and testing data, the train data values and test data values are far away from the actual values. Then we can see the clearly the future predictions with seasonality with elastic net. Here also it will not reach the up to the mark, means it will reach up to the 0.7, not up to the maximum predicted value of the radiation. Then we can go for the next model, gradient boosting G-boost model. G-boost and XG-boost models are same, but G-boost model is means somewhat is means useful for the small data sets. While we go for the XG-boost, we can use for the means complex data sets. We can work with XG-boost. G-boost model here we are using. This model also okay somewhat, means the here error is also somewhat less compared with the linear models like as linear, lasso, ridge and elastic net. Here the train data and test data is somewhat close with the actual values in training phase and testing phase. Here we see the future predictions given by the gradient boosting, winter, summer and rainy. Here we can clearly observe that maximum approximately it will give the value of 1. Then we can go for the results which are given by the ADA. See here, compare with the G-boost, ADA boost. See here, ADA boost in G-boost, the training data values and testing data values are means it is near close to the actual value. But while we are focusing on the ADA boost, it will somewhat deviated in training phase and testing phase compared with the actual values. Means the training data values and testing data values are somewhat deviated from the actual value. Then we can clearly observe the future predictions with seasonalities which were given by the ADA boost. In winter, summer and rainy, it will maximum, not maximum 0.8, from 0.7 to 0. It will reach that value, means it will not reach the maximum value of the predicted radiation. Here we can clearly observe that this is the bar chart. It can clearly explain how the train MAE is for the different models. In x-axis, it will containing the model names. In y-axis, we are the train MAE values are there. So MAE mean absolute error. So comparing with the all models, the decision tree gives the small MAE, means mean absolute error, which is small given by the decision tree. So comparing with the remaining models, the decision tree performance is good comparing with the remaining all ML models. Likewise, we are observing the test MAE. Here also, we can clearly observe that comparing with the decision tree, the remaining one, they will give the more MAE in test period. Generally, here we are classify the errors in a training phase and testing phase also. Here clearly observe that. We clearly observe that in training phase, the most of the errors are less. Why? Because the 80% of the data is trained. Here, the 20% of the data is test. Here we observe that compared with the training MAE, the testing MAE is somewhat high comparing with the training MAE. In train MAE, the decision tree error is some zero, means it is not exactly zero. It is a negligible value. For example, 0.001 like that. Here we are see the which is means the train MAE which is given by the decision tree is simply equal to the 0.08. So while we are observing these metric values, we can decide that the decision tree is works better for this data set. Then generally, whatever the performance metrics we are using in the regression data. Here the data is different types of data is there, but especially in forecasting the solar, we are working with regression data. Especially in regression tasks, we are using these four metrics like as MAE, MSE, RMSE, or MAE mean absolute error, MSE mean square error, RMSE root mean square error. R square is the coefficient of determination. It is the parameter which can decide the whether the model is best or not. For example, the R square is 1, the model is best. For example, the R square value is 0, the model is worst comparing with the remaining models. So we can easily understand that the R square value is varies from 0 to the 1. Like that, the RMSE, MSE, and MAE also vary. Here, the Y bar indicate the predicted value, and Y bar indicate the mean value of the Y. So here, how we can define the MAE? Mean absolute error is nothing but it is the difference between the mean value. Sorry, it is a difference between the predicted value with the actual values. From that mean value, we are considering as a mean absolute error. Mean square error is nothing but we can simply square the error which is given by the MAE. Nothing but we can simply square the MAE. RMSE is also simple. It is nothing but it is a square root of MSE. Whatever the MSE value is given by the data, we can simply square on it by the help of RMSE formula. Then can go for the R square. It is the formula given here. 1 minus modulus of yi minus y bar whole square, modulus of yi minus y bar whole square. Y bar is the predicted value and y bar is the mean value. I already discussed. R square value is 1 for the good means it is not exactly 1, nearby the 1 for the best models, and also R square value is nearby 0, which is the worst models. Here we clearly observe that here I am using 11 ML methods. I work on it: linear regression, random forest, XGBoost, SVM, decision tree, KNN, ridge, lasso, elastic net, gradient boosting, and ADA boost. Here, why we are clearly observe the MAE, MSE, RMSE, and R square values. Here he can clearly observe that here out of the 11 methods, random forest, XGBoost, decision tree gives the means it will give the best best compared with the MAE, MSE, RMSE, R square values. We can tell that out of the 11 models, the decision tree, XGBoost, random forest gives the best results comparing with the 11 models. Here, the decision tree gives the R square value nearby the 0.95, which is nearby the 1, and XGBoost, it will give the 0.933, and random forest, it will give the 0.94. While we are focusing on the error, the decision tree MAE is 0.02, and MSE is 0.03, and RMSE is 0.05. And we can go for the XGBoost MAE, it is the 0.036, and MSE is 0.005, and RMSE is a 0.07. Here we are observing the random forest MAE value 0.04, MSE of the random forest is 0.04, and the RMSE value is 0.06. So he from the analysis from the table, we can clearly understand that the out of the 11 models, the decision tree, random forest, XGBoost give the better results. They will containing the less MAE, MSC, RMSC values and a better R square value. Here we are observing that here MAE, MSC, RMSC are the errors. So how we can tell the model is best or not? When the MAE, MSC, RMSC values are less, means which are closely related with the zero, then we can tell that the less error indicate the model is best. And obviously the R square values should be high. So the MAE, MSC, RMSC are inversely proportional with the R square parameter. We can clearly understand that R square is the parameter which can indicate the better performance of the model, means a ML or DL, ML or DL, any model. So conclusion. Now I concluded that still now we are seeing the so many ML models with their results for forecasting of 1 year with the 1 year data of training and testing. Here I am concluded that here I am using a 1 year data from 0 to 360, means 1 to 365 days. From 1 to 272, I use the data for the training. I mean the days of data containing the solar radiation I am using for the training purpose, and the days from 273 to 365 days of the solar radiation data I am using for the testing phase. And then after the 1 year of next nothing but from 365 to 37, means around 710. I am using that a number of days for the future prediction. Here I am using 11 ML models. Out of the 11 ML models, the 3 models they give the best results comparing with the remaining models by based on their performance metrics, which we are evaluating the evaluation phase. Here we are clearly understand that we are forecasting the solar radiation in a greater way. We can easily get the better solar, means we are get higher solar radiation, means we are getting a good amount of PV energy, means we can generate solar energy in abundantly we can generate. So we cannot predict the solar radiation properly, means we are using any conventional methods like as RMI, SRMI, climatical models or numerical weather prediction models or any conventional method we are using. We are obviously we are not getting we are not getting the whatever the predicted value we want. That's the reason nowadays the all research work is going on with the ML and DL models. That's the reason I am also choosing the ML for my track to improve the to enhance the forecasting enhance the forecasting of the solar radiation in accurate way. Here in out of the 11 models, I am getting the 3 models with the better results. Here I am using the historical data. I am not using any meteorological data, any satellite data. I will in here I am only work with the historical data. Here that is historical data. I am using the parameters like as once again I will see the parameters what I am using here. Yeah, this is the parameters I am using in this in data set containing that parameters. Radiation, temperature, speed, direction, hour, and day. These are the parameters I am using in this data set. The data set containing these parameters, I work on with these parameters, and I simply feed these data parameters to the all level 11 ML models. Here we are see the 11 models. These 11 models, I feed the data to these 11 models. While we are working, I already work with these 11 models. Out of these 11 models, I will get the better results for the decision tree, XGBoost, and random forest. Likewise, so we are getting a best results. Means we are accurately getting the best predicted values for the future predictions. We definitely generate a good amount of, means huge amount of solar generation for the applications of energy management systems and grid stability, and also for the power system applications. So likewise, the forecasting is a main parameter. Means forecasting of the solar energy is the main it plays a main key role in the applications of grid stability and energy management systems, etc. Like that. So we definitely forecast the means we definitely forecast the solar data with better accurate models. Like as ML, we definitely got the huge amount of solar generation. Already we know the solar radiation is directly proportional to the solar energy. So how accurately we got the solar radiation, then obviously we can generate the huge amount of solar energy. So it leads to we can improve the means we can easily operate the grid in accurate way. So we are getting less solar energy means automatically the grid stability may be disturbed. So whatever the grid want, we can that amount of energy we want to feed. So what amount of the grid energy, what amount of the grid can require, that can be fed by the solar energy. So what amount of the solar energy we want to get, it is decided by the forecasting of the solar irradiation. So here we can clearly observe that we want a good data, means we want a exact power output which was required by the grid. We can obviously, it will depends on the prediction of the solar radiation in accurate way. So finally I concluded that the prediction of the solar radiation in accurate way is better for generating a huge amount of solar energy for the applications of grid stability and energy management system, etc. Like that. So I am now now I can stop my presentation. Please, any questions? Please ask me. Thank you for listening this lecture. Please ask any questions you have. Anyone, please ask any question.
Hello.
Hello, tell me, sir.
Uh, Very good evening, sir. Myself, Dr. Prakash. I'm from Bharat
Yes, sir.
Institute
Tell
of
me,
Higher
sir.
Education.
Yes, sir.
Sir, whether actually we don't have any questions to ask. So, how
Yes, sir.
machine language is implemented in all the problems like this? Whether like this, any basic things related to electrical or the power converters like that, whether machine language is applied, any references or any books, anything you can tell, sir, so that it will be easy for us to share with the students also.
Yes, sir. Yes, sir. Yes, sir. I can understand what you are asking, sir. Sir,
Yeah.
actually, actually, my Arnab sir told me to search the papers in Google Scholar, sir. First, I will go the Google Scholar. First, I will gather the data, sir. Means I will gather the reference papers, sir, which were containing the forecasting. Actually, my project is, sir, forecasting the solar and wind energy using ML and DL methods, sir. So according to my project, I can work on it. So first I can use the Google Scholar. First, whatever the means papers I want, I can download, sir. Means here I am not using any textbook. Means, sir, actually the textbooks and the data source means data available that they will contain in the world methods. Means, sir, I think everyone know in research paper whatever the new technology happen, it will simply described in the papers. So likewise, my sir suggest me that you will go for the papers. Especially my Arnab sir told me that you can go for use the standard papers like as IEEE papers, and also Springer like that. Also a size direct papers like that. High level of journal papers I can use. Sir. I will gather around for the solar. I gather around solar forecasting. I think I gather around 50 papers like that. Out of the 50 papers, till now I will complete the 20 papers around like that, sir. Here I am showing the 10 papers, and I think around I will complete the 20 papers. So the thing is that whichever the problem we have, according to that we can download the paper according to that. And also, sir, in some papers they will containing the data also, means how to implement the Python code, how we can write the Python code, means how we can means write the code lines for the means algorithms, how we can call the data set, how we can give the data set, sir. Actually in ML, sir, first we can write the Python code, we can run the Python code in Jupyter notebook or Colab in Spider or any library. Means any Python library we are using here. So means any platform we are using here. Still now I am using a Jupyter. Sorry, still now I am using a Jupyter notebook and Colab for running this all ML programs. Here, first we
Okay.
are writing ML code, sir. In that ML code, first we can call the data. Means first we can upload the data set using the .csv file. Sir, here the data set. I think so many papers they will easily means the authors who are write the paper they will easily give the data sets. I think that some people don't give. Means in acknowledgement they will give a comment like that. By based on the request we will provide the data like that around two to three papers. I will send the request mail to them. They will send data. And some papers,
Oh,
the data set are easily downloaded from the GitHub. So GitHub is a source. We can download data, I mean, so data sets easily like that.
okay,
Like
sir.
that I am
Sir,
doing.
thank you.
Okay,
Thanks,
sir. Thank
thanks
you,
for
sir.
your information, because I also
Okay, sir.
want my students to go project with this. So that's why I asked the
Yes.
question. Thank you.
Yes, sir.
Thanks
Yes,
for
sir.
your.
Thank you, sir. Thank you, sir. Thank you, sir. Any questions, please ask me.
Yes, sir. Myself, T. Kishore Babu.
Tell me, sir.
Sir, in SVM machine learning, we are using
Yes.
use hyperlane and margins.
Yes, sir. Yes, sir.
So hyperlane indicates what, sir, and margin if less than, if less, what it is
Sir, I
represent.
can. Yes, sir. Yes, sir. I can see the show the diagram. I can explain. Sir, hyperplane here it will look like a one dimensional plane, a 1D plane
Yeah.
like that, but it is a two-dimensional plane, sir. Here for figure it
Okay.
will give like this. It will expand, sir. It will expanded, and also it will collect the data features. I already told now, sir. For example, the blue lines indicating temperature feature variables, and also the red
Yes.
indicating the cloud cover. We are not taking any variable like that from the especially we are targeting the solar radiation here, sir. So
Yes, sir.
whatever the data points which are means which are related with the in linear relation or non-linear relation, the data points are easily margin by the means collected by this margin, sir. From the data points which will feature means which will be work with against with the solar radiation.
Okay, sir.
Okay, sir.
Thank you, sir.
Okay, sir. Thank you, sir. Sir, any questions, please ask.
Okay, I hope there is no other queries. So,
Okay, sir.
so can I conclude now, Thirumala?
Yes, sir. Conclude, sir.
Okay, okay, thank you. So, our last session, we are going to, just for a moment, yes. Thank you, Thirumala, for your
Thank you,
presentations.
sir.